Have you ever been stuck in a packed coffee shop, your Wi-Fi just crawling along? Or maybe you're at a concert and your call drops. It really feels like we're just running out of airwaves. But what if I told you the problem isn't a lack of space, but a lack of smarts? Well, let's dive into the world of cognitive radio, a technology that's promising to make our wireless connections not just faster, but genuinely intelligent.
So first, let's talk about the problem everyone thinks we have. Our airwaves are just too crowded. I mean, every single device, from your phone to your smart toaster, is basically shouting into the same invisible space. They're all competing for a little slice of the radio spectrum. It seems like a pretty classic case of way too much demand and just not enough supply.
But here is the big twist. This idea of a completely full, totally packed radio spectrum, it's pretty much a myth. While it absolutely feels crowded to us, a huge chunk of it is actually silent most of the time. So, what's really going on here?
Well, you see, we treat the radio spectrum like a bunch of private properties. We license out specific frequencies to specific users. But look at how that actually plays out in the real world. TV broadcast bands, largely empty. Emergency service channels, they're absolutely critical, of course, but they're silent almost all the time. Even our own cellular networks have these huge gaps during off-peak hours. This just shows the real issue. We don't have a scarcity problem, we have an efficiency problem.
These empty spaces actually have a name. They're called spectrum holes. The best way to think about it is like a sold-out movie theater. Okay, just because every single seat is owned doesn't mean every seat is occupied for the entire movie, right? A spectrum hole is just like that empty seat. Someone else could totally use it for a little while without bothering the person who actually bought the ticket. Finding and using these empty seats is the whole key.
Okay, so if the big problem is all these empty, wasted spaces, how do we fix it? Well, we need a totally new kind of radio. Not one that just stays in its own lane, but one that can intelligently and, more importantly, politely find the open road.
And that brings us to the hero of our story, the cognitive radio. Now, this isn't just a programmable radio, it's an aware radio. It has the smarts to constantly sense its environment, identify those spectrum holes we talked about, and then opportunistically jump into them to send its data. And just as important, it knows how to get out of the way the second the primary user comes back.
So this whole system works with two types of users. First, you've got the primary user. That's the licensed owner, the homeowner, you could say. They always have priority. Always. Then you have the secondary user, which is our cognitive radio. And it's like a really polite guest. It uses the space when the owner isn't there, but the second the owner returns, the guest immediately leaves, without causing any interference at all. It's the ultimate in good radio manners.
Now this all sounds fantastic in theory, right? But it brings up a huge technical challenge. Before a radio can be polite, it has to be able to listen. It has to know when the room is quiet enough to speak. So how does a piece of hardware actually do this? This complex act of listening. How can it tell the difference between a licensed user's very faint signal and just, background noise? Let's look at the most basic way it can be done. The simplest method is called an energy detector, and its logic is incredibly straightforward. First, it scans a frequency. Then it measures the total radio frequency energy it finds in that band. Next, it compares that energy level to a threshold that's already been set. If the energy is below that line, the detector just declares the channel empty. Simple, right?
Well, maybe a little too simple. The energy detector is definitely fast, but it's not very smart. It can't tell the difference between a primary user's signal and any other kind of radio interference. So its performance just tanks in noisy environments, and it's prone to false alarms, thinking a channel is busy when it's really just noisy. To really solve this problem, we need a radio that doesn't just sense energy, we need one that can actually think.
This is where we make the huge leap from just a simple sensor to a truly cognitive system. It's kind of the difference between a smoke alarm that just beeps at any kind of smoke and a chef who can tell you exactly what's burning, why it's burning, and what to do about it.
This whole idea was captured perfectly by Joseph Mottola, who's basically the father of cognitive radio. He said the goal was to make radios trainable instead of just programmable. The radio shouldn't just be following a fixed set of rules. It should be able to learn, to adapt, and to make intelligent decisions based on what it's experienced. And this right here is the brain that makes it all happen, the cognition cycle. You can think of it as this continuous loop. The radio observes its environment by sensing the airwaves. Then it orients itself by analyzing all that data. From there, it plans a few potential actions, it decides on the absolute best one, and then finally it acts, reconfiguring itself to use that open channel. This loop, running over and over, is what makes a radio truly cognitive. So we've got a problem of wasted space, and a technology that can literally think its way around it. What does this actually mean for us in the real world? Well, the implications are absolutely massive.
The first huge application is something called spectrum pooling. See, with cognitive radios, we can stop thinking of spectrum as these fixed, private lots and start treating it like a giant shared resource pool. This basically creates a real-time marketplace where our devices can rent unused spectrum for just milliseconds or maybe hours, only paying for exactly what they need right when they need it.
And the size of this opportunity, it's just staggering. Look at this number. In the US alone, some studies suggest that cognitive radio could open up nearly 1.5 gigahertz of mobile spectrum that's currently being underused. That is an immense amount of new wireless highway that could be made available, and it would dramatically increase capacity without us having to lay a single new fiber optic cable.
And all this new capacity, it unlocks an amazing future. I mean, imagine real-time auctions for bandwidth, networks that are so efficient they feel infinitely fast, emergency services having guaranteed clear channels in a disaster. Or how about a phone that learns your commute so it can optimize its connection through any dead spots? Ultimately, our devices would just manage our connection so seamlessly, the wireless world would just work, and we'd never even notice the complexity behind it.
All of this leads to one final, really fascinating question. You see, for decades, our devices have been pretty simple endpoints on a very smart network. But cognitive radio completely flips that script. It creates incredibly intelligent devices on a network that is, by comparison, pretty simple. This shift could fundamentally change how we build and manage our entire wireless world, paving the way for a future that we're really only just beginning to imagine.